Hi, in this video I'm looking at doing this integral here of 3e to the 4x x squared dx. Now this integral is the product of two functions. I've got one function here, e to the 4x, and the other function here, x squared, and they're multiplied together. So to do an integral with a product of functions, I want to use integration by parts, which says that if I have the integral of some function u times by the derivative of some other function v, then that integral is that function u times that original function v that came to make that derivative minus the integral of the derivative of that function u times by that original function v that gave us the derivative v dash. So this is the rule I'm going to use to solve this problem. I've just got to work out which is going to be u and which is going to be v. Before I get started on that, I'm going to take out this constant 3 out the front, just so that it is not going to be in our way throughout this process. So we have e to the 4x, and we have x squared. And which one do I want to be u, so that it derives down and becomes inside my integral? And which one do I want to be e, which I've got to integrate, and it turns up in and outside my integral? Now, to pick, you want to pick u first. U needs to be the function that will derive down to something that effectively cancels out or is nothing within an integral. It means nothing. So with u, we want to pick the one that will derive eventually down to something that's a constant or is very easy to integrate. Now, if I picked e to the 4x for u, the problem with e to the 4x, if I derive that, it just again becomes e to the 4x times 4, but we still have that e to the 4x. And if I integrate e to the 4x, though it ended up in here as u dash, then I'm just going to get back to e to the 4x. So it's not going to help us. And if I pick x squared, it derives down to 2x, which is simpler. So it might help us out. So I'm going to make u be our x squared. And I'm going to make v dash, the derivative of an original function, be e to the 4x. So now deriving it to get u dash, so u dash is going to be 2x, and v is going to be the integral of e to the 4x, which is going to be e to the 4x divided by 4, because I've got to divide by the derivative of the 4x, which is just 4. So now, if I have a look at my integral that I'm caring about, I'm just focusing on this single integral, e to the 4x, x squared dx, and I'm going to apply our integration by parts rule to this. So following it, I've got u, which we have here as x squared, multiplied by v, which we worked out here is e to the 4x on 4, minus of the integral of u dash, which we worked out as 2x, times v, which is e to the 4x on 4 with respect to x. So now I've got this integral here, which I need to sort out. So let's tidy it up a bit first. So this gives us x squared e to the 4x on 4 minus 2 over 4 becomes a half. So I'm going to bring that half out the front. Integral of x e to the 4x dx. So now I've got to sort out this integral, x e to the 4x dx. Now the problem with this integral is it's still a product of two functions. I still have x, which is a function, times e to the 4x, another function, which means that I now need to work out temporarily this other integral, the integral of x e to the 4x dx using another integration by parts. So let's go through the same process. Let's let u be x, because it's going to derive down to 1, which is nice. And v dash be e to the 4x. So deriving u to get u dash, we have 1. Integrating v dash to get v, we have e to the 4x on 4. So now our integral of x e to the 4x dx is going to be, following our integration by parts, u, which is x, times by v, e to the 4x on 4, minus the integral of u dash, which we have as 1, times v, e to the 4x on 4 with respect to x. And this I can do. I can do this integral because it's just e to the 4x on 4. So let's take out that constant of a quarter there. So we're going to have minus a quarter integral of e to the 4x dx. So I've just got to do this integral. So my integral of x e to the 4x dx is going to be x e to the 4x on 4 minus, we've got the quarter, and e to the 4x integrated becomes e to the 4x on 4. And so tidying this up, we get x e to the 4x on 4 minus e to the 4x, quarter times a quarter, 1 on 16. So we have this integral part here is e to the 4x, x e to the 4x on 4 minus e to the 4x on 16. So now we're going to take this and we're going to plug it in up here. So this integral is going to become x squared e to the 4x on 4 minus a half outside of, and we've just worked out this integral of x e to the 4x is x e to the 4x on 4 minus e to the 4x. So let's plug that in. So we've got x e to the 4x on 4 minus e to the 4x on 16. So now I've plugged in that integral. So now we've just got to tidy this up. So if we do a little bit of expanding this half in, so I've got x squared e to the 4x on 4 minus x e to the 4x on 4 times a half is going to be x e to the 4x, a half times a quarter is an eighth. We got negative times a negative when we go to our next term, so I'm going to have plus. And I've got e to the 4x on 16 times 2 is 32. So we're getting somewhere. What I'm going to do at this point is get all of this over 32, because this is my main integral. I've started up here. All I've got left to do is multiply everything by 3. But before I do that, I'm going to get all of my denominators all over 32, just to make it nice. So to do that, I've got to have a look. What do I do to 4 to get it to become 32? Well, 4 eighths are 32. So I've got to have 8 x squared e to the 4x on 32 minus, what have I got to do to 8 to get it to become 32? I've got to times it by 4. So times top and bottom by 4 gives us 4x e to the 4x on 32 plus e to the 4x on 32. So finally, this integral e to the 4x x squared dx is 8x squared e to the 4x minus 4x e to the 4x plus e to the 4x all over 32. So now I can go and substitute into this integral. So now we want to have 3 times the integral of e to the 4x x squared dx, which is going to be 3 times all of this. So 3 times 8x squared e to the 4x minus 4x e to the 4x plus e to the 4x all over 32. And so now if I do a little bit extra tidying up and I multiply this 3 in, I've got 3 times 8 is going to give us 24 x squared e to the 4x. 3 times 4 is going to give us minus 12 x e to the 4x. And 3 times e to the 4x is going to be 3 e to the 4x, and we're still all over 32. And so now I've basically got my answer. So I started off with this integral, so I'll write my answer in terms of this integral. I've got the integral of 3 e to the 4x x squared dx. And I'm going to do one last tidying up step while I do this. I'm going to factorize out this e to the 4x. So I'm going to have bracket. Focus on just the x parts and ignore the e to the 4x's for now. I've got 24x squared minus 12x plus 3. Whoops, I missed the plus here. Factorize out that e to the 4x because it's common through all of those, all over 32. And we have our answer. The integral of 3e to the 4x x squared dx is 24x squared minus 12x plus 3 all times e to the 4x all over 32. And we got there because I had a product of two functions, so I used integration by parts. But that unfortunately gave me the integral of a product of two functions. So I had to again integrate by parts. But that thankfully gave me a straight answer. So then all I had to do from there is substitute that in, tidy up, substitute that into our other one, tidy up, and we've got our final answer.